In the 1998 science fiction classic Deep Impact, the film comes to a dramatic crisis point as a large asteroid slams into the Atlantic Ocean. Given that the Earth's ocean covers 71% of its surface, a deep impact event such as the one portrayed in this film is more likely than any other impact scenario. This is of grave concern because recent population studies tell us that the overwhelming bulk of humanity lives along or near a coastline. And what you're going to see in this program is that this concern is now greater than ever before. And worse yet, the threat has begun to skyrocket in the last few years. Deep within each of us is a racial memory of rocks falling out of the sky and killing people. And sometimes it's a little difficult for us to handle. So like children, we turn on all the lights, lock the closet door, jump into bed and pull the covers over our heads and say, if the monsters can't see me, they can't hurt me. Well, you know, there is a little bit of truth to that because asteroids and superbolides cannot see us. But that will not stop them from killing us. On February 15, 2013, a superbolide meteor blindsided everyone on the planet, including NASA and the Russian Air Defense System. Entering Earth's atmosphere at a shallow angle, it growled through the skies at 60 times the speed of sound and detonated over a remote region of the Chelyabinsk Oblast at an altitude of 18.4 miles above the ground. Thankfully, nobody died, but nearly 1,500 people were injured, including 311 children. There were a few serious injuries, but most were hurt by glass falling on them, or worse, having shards of glass blown into their faces by the detonation as they looked out their windows to see what was growling across the sky. When the superbolide detonated, it was momentarily 30 times brighter than the sun, which caused hundreds to suffer eye pain and temporary flash blindness. This is because when the Chelyabinsk superbolide detonated, it released 30 times as much energy as the little boy uranium bomb dropped on Hiroshima on August 6, 1945. One can only imagine the death and havoc an event such as this would have created had it detonated over a major city like Paris, New York, Moscow, or London. And so as the story faded from the front page, as all stories do, it was out of sight and out of mind for most. But for a few in the science community, the event triggered a new awareness that perhaps we'd become complacent about the threat of an impact event. Nonetheless, when it does come, and it will do so with a vengeance, what will you do then? Where will you drive to when the streets become parking lots? And where do you hide from a mountain of water? Nowhere. This is why in the first program in this series, Planet X 101, Who, What, When, Where, Why, and How, we presented our initial analysis of fireball observation reports. Our source is the American Meteor Society, and you can learn more about this reporting site at amsmeteors.org. For over a year we've been studying their reporting data, and what it told us is that for those living along a coastline, it's time to bust a move inland. In my case, it was from Santa Cruz on the northern California coast to Reno, Nevada. But that's just me. As for you, if you live along a coastline and you're watching this, then I also suggest you visit our site at yowza.com, that's YOWUSA.com, to read my article, It's Time to Bust a Move. Then you decide for yourself. In this program, we're going to give you a detailed analysis of AMS Meteor Observation Report data. Let's get started with yearly trends. At Yowza.com, what we're tracking are fireball reports, those big ugly rocks that fly through the sky and make the evening news. And this year started with an interesting twist, so to speak. So let's get caught up. The AMS reporting data presented in our first program in this series, Planet X 101, Who, What, When, Where, Why, and How, was through to October 2013. In this program, we'll update that to include the first quarter of 2014. So let's get started. Here we see the complete actuals for all of 2013. Based on those 2013 actuals, here are the monthly estimates for 2014. Now let's see how the 2014 estimates compare with the first quarter of 2014. In January, the estimate is spot on. The actual for January is consistent with the estimate based on the prior year actual. However, in February, we see a drop, not only from the estimate, but from the February 2013 actual as well. Again in March, we see the same thing as February. The actual is below the estimate as well as the prior year actual. So what could account for this? First off, we're not talking about meteor showers like the Perseids, which many of us enjoy watching on warm August nights. Rather, we're tracking fireballs such as the one observed over Japan in January of this year. Large, solitary rocks that come screaming out of the heavens. With that in mind, here is one explanation for the first quarter drop in fireball observation reports. As we've reported, we're tracking an approaching second sun in our system. Astronomers have named it Nemesis. It is the core of what we refer to as the Planet X system. Nemesis is a brown dwarf companion to Sol, with its own planets and rings as well. To illustrate one explanation for the drop in the 2014 first quarter fireball observations, let's use this illustration of the rings of Saturn as the backdrop for our example. In this case, the data could be telling us that Earth is now between the bands. Therefore, we do not really know what is coming next. Another bigger band? Or could it be over? With either scenario, the terms coincidence and natural variability come to mind. They did for us, and for that reason, we dug hard into the data. And here is what we found. Let's assume that the brown dwarf at the core of the Planet X system is like the other massive objects in our solar system, in that it is also surrounded by rings. So, are we encountering those rings? If so, how would it be expressed in the data? Let's see. For the purpose of this study, we're going to use a line graph instead of a bar chart. And here we are starting with the 2013 to 2014 actuals based on current AMS reporting data. Using this data, we can project through to the end of 2015, and this shows a steady uptick. Then when we extend the projection out to 2016, we see an even greater uptick happening. And finally, when we go to the end of the projection in January 2017, the trend does appear ominous. With this in mind, let's see where the Chelyabinsk super bolide that detonated over Russia on February 15, 2013 fits into this picture. Here we have added the Chelyabinsk super bolide to our previous timeline. What it shows is that there has been a steady uptick in actuals since that event. However, when we expand the timeline to cover the period 2009 through January 2017, this is when we really begin to get a sense of what is happening. This is not coincidence, nor is it natural variability. And if you're living along a coastline, you should be concerned. Now let's take a look at multi-state observations. The interesting thing about the Chelyabinsk super bolide that detonated in the skies over Russia last year was that it came right out of the sun. And so both the Russian air defense system and NASA were completely blindsided. This is why we take a special interest in multi-state fireball reports, as these tend to be large fireballs or super bolides with shallow trajectories such as the Chelyabinsk super bolide. It's not uncommon to see reports coming in from 3 or 4 states for these large fireballs, or in some cases, 2 or more countries. So let's see what the data tells us. Here we see the updated actuals for all of 2013, which tracks closely with the yearly trends we saw before. Using those actuals, we were able to project estimates for 2014. So let's see how the estimates compare with the first quarter of this year. In January, we're seeing that the estimate and the actual are spot on. While the February actual is well below the estimate, it's not that far off from the 2013 actual for February. And in March of this year, we see that the actual is on par with February, but significantly lower than the actual for 2013 as well as the estimate for this year. But if you think we're out of the woods, don't draw that conclusion in haste, not until you see what we have next. The AMS data set is very rich with many different types of data, but the one that really gets our attention the most are called huge events. In the first program in this series, Planet X 101, Who, What, When, Where, Why, and How, we introduced viewers to the AMS classification system, where mid-sized events get 6 to 20 reports, significant events get 21 to 50, and large events get 51 to 100. Huge events get 100 plus reports. The huge classification is usually reserved for the biggest, brightest, and noisiest space rocks. These are the ones we need to worry about, so let's take a look at the trend data. Here we see the actuals for 2013, and the first thing we can't help but notice is that it's a bit spotty. Then, using the general trend projection, we created 2014 estimates for huge events. So let's see how the estimates fit with the actuals so far for this year. With January of this year, what we now see is a reverse in the earlier trend data for the first quarter, which shows several reporting types with lower values. Then in February, a surprise. Since there were no prior year actuals for this classification, we could not make a prediction. Nonetheless, there were 2 huge events in February. It's also interesting to note that there were no huge events in March. So was February a fluke? We wondered about that ourselves. But as we were finalizing our study, a huge event occurred in April. Like February of this year, there was no estimate because there was no prior year actual. So while we are seeing a downward trend for the first quarter and the earlier categories we showed you, what we're seeing with the huge classification is anomalous and disturbing. To help put this in context, we're now going to present the two most significant trends in this report. We're now going to show you the two most significant trends: huge events and multi-state events. We are going to use 2013 actuals for multi-state events and huge events to set a baseline for this comparison. And here we see the addition of the 2014 estimates, which track closely with the 2013 actuals. With this in mind, we are going to see how the first quarter of 2014 compares with the 2013 actuals and 2014 estimates. Here we see that January 2014 is right on track with the 2013 estimate for multi-state events, but a little higher for huge events. For multi-state events in February 2014, we see a drop below the 2013 actual level. However, huge events are still significantly above 2013 actuals and 2014 estimates. In March, we see the downward trend for multi-state events has leveled out a bit. But on the other hand, it has plummeted in terms of huge events. Once again, we factor in the late reporting data for huge events in April of 2014, and we see an uptick that does rise above the 2013 actuals and the 2014 estimates, while at the same time we're seeing a virtual flat line on multi-state events. In terms of similar reporting outside the U.S., we did not find any sources as competent or as thorough as the American Meteor Society, but this is what we did piece together. There was no significant reporting of fireballs until September 2013. Since then, we've been able to follow two principal areas. In Europe, we're seeing multi-country reports that span all the way across Europe, over the UK, and some even as far as Ireland. In Oceania, we're seeing multi-country reports that span the distance from New Zealand to Australia. These observations are based on the timestamps of the reports. Given that 71% of the surface of our planet is covered by oceans, we believe that unless these trends dramatically reverse themselves this year, there is a high likelihood of a deep impact event in our near future. This was a key factor in my own decision to bust a move from the Santa Cruz area of California to Reno, Nevada. Now, for those of you living along a coastline, I hope you take the information presented in this program to heart, and that you do the same. And just remember, every day of procrastination is one less day of survival options. And I'll leave it on that note. So until the next time we meet, remember Marshall's motto: destiny comes to those who listen and fate finds the rest. So learn what you can learn, do what you can do, and never give up hope. This is Marshall, and I'll catch you on the backside.